Hi, and welcome to the first of hopefully many videos in which I, Jascha, will be tackling some past paper math questions. Today, Math AA standard level. If you're high level videos will be coming out soon. Today we'll be looking at 3 past paper questions from the 2023 exams on calculus, as I find that is probably the most tricky subject, so that's what we're starting with. And I'm going to take it nice and slow today. Hopefully all the explanations are nice and clear. And yeah, let's get right into it. A little bit about myself before we get too deep into the questions. I've been a tutor for Lanterna for 3.5 years now, goodness me. I graduated top of class in math myself. So I'd say I should hopefully know what I'm doing here, but let's see. Let's get into it. Okay, so this very first question we have right here, let's just take a quick second to read it. Actually, before we do, let me show you guys where I've gotten it from. So in the top right corner, it'll always say where I found the paper and if calculators allowed or not. So obviously paper 1, no calculators. And in this question, we have a beautiful graph that is called y equals x over x squared plus 2. Only for positive x's, people always like to ignore this, but keep this in mind, this is very important. Always read it if it says so. And we have a shaded region, and we know the area of this shaded region, so I'll just write that in here. The area of R, this shaded region, is ln3. Okay, lovely. Now, I also have this little section right here, the bottom, where I will be showing you the formula that we will need from your data booklet. Do yourself a favor and always know where things are in the data booklet. Practice all your math practice, always have your data booklet out. Make sure you know where everything is. It is extremely important. Okay, so what do we need for this? Well, we've got an area and we need to find this value right here, this c. So this is some line called x equals c, right? And basically we need to find out what that is to make the area ln3. Okay, well then we can use this lovely formula right here, this formula for the area. So we know that AR is ln3, so this is going to be a tiny bit cramped, so bear with me here, guys. So we'll say ln3, that is the area R, right, must be equal to the integral from the lower boundary to the upper boundary. Well, what's the lower boundary? We start at 0. So from 0 all the way up to c. So this c is what we're going to be trying to find in this question. And it then says the integral of y dx. So y in this case is x. It is x divided by x squared plus 2 dx. Now a lot of students always like to ask, why do I need the dx? That just confuses me. Well, the dx is really important for telling you what variable we are integrating. So imagine there was like a constant in here called a, right? Then we wouldn't know, are we integrating x or are we integrating a? So that is quite important to remember to include this dx. Right, now the big question, how in the world do we integrate something like this? Well, it certainly doesn't look too easy, and there's nothing in the formula booklet that's going to help you here. So what I like to do when I need to integrate something that looks really complicated is to try and see what happens if I try u substitution with the most complicated thing in the formula. So if you don't remember what u substitution is, no worries, we'll walk through it right now. So I'll just make a quick line over here, so the stuff to the right side of the line has nothing to do with the stuff on the left side. Actually, you know what? Let me maybe use a different color here. Haha! Look at this technology. Let me say that u equals x squared, because in my opinion, x squared is the most complicated looking thing in this equation right here. You know what, let's call it even x squared plus 2, so that's the entire bottom row down here is u. Okay, what do I need to do in u substitution? Well, now I need to find du divided by dx, because I can't just substitute u in just yet, because I've got this dx I need to get rid of first. So du dx, what does that mean? That means u differentiated in terms of x, right? So what is this differentiated? Well, I hope you guys remember there's a formula for this, but I'm going to do it without here. So x squared differentiated means we bring the 2 down, right, in front, x, and then to the power of, well, we go 1 down. So what is 1 down from 2? That would be 2x to the power of 1, also just known as 2x. And plus 2, well, any constant, when you differentiate it, that just disappears. So this is just the same as 2x. Okay, now I need to isolate the dx so I can replace it with the x the dx right here. Okay, so how do we do that? Well, I would start by multiplying dx on both sides. So I'm going to write it like this. Maybe you shouldn't write it like this in your exams, but you can if you want to. This just means both sides multiplied by dx. That long line just means all sides multiplied with dx. So maybe I'll do a little multiplication symbol there as well. Okay. Then I will have, if I multiply dx through by everything, then I will get du equals 2x dx. But I want just dx on its own, so I need to divide by 2x on both sides. So again, I'll do my line and I'll say, well, multiplying by 1 over 2x is the same as dividing by 2x. And then finally I get that du divided by 2x equals dx. Lovely. Okay, why is this important now? Now I can switch back to red so that we can go back to the question. We can now substitute in for u. So we can now say that this is going to be equal to the integral. Now we need to be a little bit careful with the boundaries. I'll get back to that in a second. X stays x. X squared plus 2, well, that's just u, right? Now instead of dx, look, I'm going to write what I had over here. I'm going to write du divided by 2x. Great. Okay. What about the boundaries? Well, the boundaries, these were x values. So now we need to turn them into u values, if that makes sense. In other words, we need to take these values and put them into our expression for u. So this would be 0 squared plus 2. Well, that would just be 2. And this would be, the top would be putting c in for x in our u expression, so that would be c squared plus 2. So c squared plus 2. Okay. So far, so good, I hope. Now, what can we immediately see? Well, if you're quick, you can see, well, we've got an x on the top, an x on the bottom. Well, fractions are nice. They just cancel out. So these x's we can cross out. They disappear. So then we are left with the integral from 2 to c squared plus 2 of 1 over u du divided by 2. Now this divided by 2, we can just actually take that outside in front. Whenever you've got a factor that multiplies everything when you're integrating, you can just take that out into the front. So then I will just really quickly do that. I will take the 1/2, I'll put that out in front. Remember, that only works if it's multiplied by everything. So, and then we have 2 to c squared plus 2 of 1 over u du. Okay, then we take a quick look in our formula booklet. How do we integrate 1 over u? Maybe you already know this by heart. If you do, that's great. Well, we've got this in our formula booklet right here. 1 over x integrated is ln absolute x. Okay, so that means we've got 1/2. Now we need to do these square brackets. You can also write it with a long line on the side, but I do square brackets. ln u. Now I could say ln absolute u, but u by definition has to be a positive number because it's x squared, right? So anything squared is always positive. Plus 2, so something positive plus something positive will be positive. So I'm not going to bother with the absolute signs, because remember, what do absolute signs do? They just turn any negative number into a positive number. But everything's positive anyway, so I'll just ignore those. Okay, and then we need to write the boundaries on the top, so c squared plus 2 and 2 on the bottom. We don't need to think about the plus c when we're doing a definite integral. Definite integral just means we have a lower and upper bound like we do here. And then we need to put in the top and then say minus the bottom. So I will say 1/2, and then we'll say ln, putting the top in, so that will be c squared plus 2 minus ln 2. Okay, can we simplify this? Yeah, I hope you know your log laws. If not, they are also in your data booklet somewhere in, I think, section 1. So we can simplify this to 1/2 ln, it's going to get a little bit cramped, c squared plus 2 divided by 2, like so. And remember, what was this all equal to? Well, this was equal to ln 3, right? Because this is the area. So don't forget that. Now, it's been a long time since we mentioned that. So we've got ln on both sides, but right now we've still got this pesky 1/2 in front. Now, again, we go back to log laws. If I have a constant in front of a logarithm, because remember, ln, that's nothing but logarithm base e, right? E is just a number, 2.7 whatever. Okay, so that means I can rewrite this as ln 3 equals, with the 1/2, I can just move that up into the power. So I'll say ln c squared plus 2 divided by 2 raised to the power of 1/2, like so. And raised to the power of 1/2, that's nothing else but the square root, right? So finally I end up with, we're really running out of space here, but we'll manage, guys, we'll manage. We'll get 3 equals the square root of c squared plus 2 divided by 2. Now, if we do some rearranging here, we square both sides, multiply the 2 over, subtract 2, take the square root, trust you can do that, then we actually end up getting that c is plus or minus 4. Now, the question is plus or minus, we need to choose one. Well, if we look back in the question real quick, then we will see that we have a definition that x has to be a positive number. You can actually also kind of see it in our sketch, right? C is clearly a positive number. So, lo and behold, we finally get that c will be equal to positive 4. And that will be our answer right there. Great. Okay, that was the first out of 3 questions. So I'd say we'll just keep going. And here is the next. So again, I'll give you a second to read, or I'll say the most important bits myself. Pause the video here. Again, I'll say that actually for any exercise. Try and pause the video before I solve it and see if you can solve it yourself. And then, you know, if you can't, maybe wait for the first hint from my side and then try and solve it. So I hope you've done that. I hope you've tried to solve this yourself. And let's see if we can clear up any questions you have. So we've got a circle with an equation x squared plus y equals 9. Ooh, that looks scary. We haven't seen anything like that before, maybe. And a radius of 3. Okay, so it's just a circle with radius 3. Has some complicated equation describing it, but I think we're fine. A triangle is inscribed, fancy word, with vertices, so 3 different points basically is what that means, P, Q, and R. The formatting is a little bit off. This should be R is x, comma, negative y. And it is shown in the following diagram. Okay, we need to show for point Q, so point Q, that would be this point right here. Just change colors for a new question. You know what, let's go with this lovely purple. So we need to show that for this point, the y-coordinate is the square root of 9 minus x squared. Okay, well, the x-coordinate is just some arbitrary x. So what do we need to do? Basically, we're just solving for y now in this equation we have on top. So let me just rewrite this equation real quick over here on the side. We've got x squared plus y squared equals 9. All right, what do we need to do? Well, we just need to isolate for y. Okay, how do we do that? We say minus 2x, or minus x squared on both sides. So then we end up getting y squared equals 9 minus x squared. And then we need to take the square root of both sides to get rid of the squared. And then we get y is equal to plus or minus, whenever you take the square root, right? Plus or minus 9 minus x squared. Now the question, does it have to be a positive or a negative value? Well, Q clearly is in the positive quadrant, right? So we can conclude that the negative is irrelevant. Negative is irrelevant, like so. And we get positive. And hence we've shown that y is the square root of 9 minus x squared. Lovely stuff. Okay, next question. Hence, find an expression for A, the area of the triangle, in terms of x. Now, I've included a little formula down here. So, the area of a triangle is a half base times height. I'm sure you've heard that formula many, many times. But what is the base and what is the height? Well, I would say this right here to me looks like a base, right? And this right here looks like a height. It's just tilted by 90 degrees, but you know what? It's the same principle. So what's this base? Well, this base right here, clearly, that goes from positive y to negative y. So how long is it? Well, 2y. And what was y? Well, y, we just showed that in the previous exercise. That's nothing but the square root of 9 minus x squared. Okay, so that must be our base. Lovely. What's our height? Well, our height can be broken down into two components. One would be this right here on the, excuse me, this right here on the negative side of the x-axis. That would be from 0 to -3. So this right here would be 3 long, right? And then from here to here, does not like me today. No, technology. Like so, that would just be x, right? So going from the 0, I'm going x out. So the height, what is the height then? Well, the height would be 3 plus x, okay? So then the area, well, that was what we wanted, right? So then the area would be 1/2 of the, let's say the base, so that would be 2 square root 9 minus x squared times the height, 3 plus x. Okay. Okay, let's take a look at this next exercise right here. So what do we need to do? We need to show that dA differentiated, well, so a differentiated in terms of x equals this scary looking term right here. We'll manage, don't worry guys. But I think let's just very quickly remind ourselves, well, what was a? Well, we found that in the previous question. A was, actually, let me very quickly just go back. Look at this, guys. 1/2 times 2, well, they just cancel out, right? So actually a, what would a be? That would just be the square root 9 minus x squared times 3 plus x. Okay, so let's just write that on the slide as well. So we've got the square root of 9 minus x squared times 3 plus x, like so. Okay, we've got two things multiplied. What do we need to use when we differentiate two things that have been multiplied? We use the product rule. So for the product rule, we need some u times some v will be the u times the v differentiated plus the v times the u differentiated. I'm sure you've seen this rule a million times before. Okay, so let's just quickly define what is u and what is v. Well, I'll say u is the square root of 9 minus x squared. And then v, consequently, of course, has to be 3 plus x. Okay, now we need to find du dx. Well, to find du dx, I actually think it's useful just to remind ourselves, I said this earlier as well in this video, 9 minus x square rooted. When I square root something, that's the same as if it's to the power of 1/2. So I'll just quickly rewrite this as 9 minus x squared to the power of 1/2. I think differentiating square roots becomes easier when we think of them this way. Because then what do I do when I differentiate something? So let me just write u differentiated in terms of x. Well, I bring the 1/2 down, right? 1/2 comes down. And then the inside bit, that just stays the same. We need to use the chain rule here. So 1/2 comes down. And then we go down in 1 in power. So 1/2 minus 1, that becomes -1/2. But like I said, this is the chain rule. So we just differentiated the outer function, what's on the outside, right? The power to 1/2. In the chain rule, you then always need to multiply with the inside bit differentiated. What's the inside bit? Well, that would be the 9 minus x squared. So what is that differentiated? Have a quick think. Minus 2x, right? So times minus 2x. Okay, I can immediately spot I've got a 1/2 and a 2. Beautiful, they just cancel out, right? And ultimately, du dx, that is nothing else but, and again, if I have a negative, so I'll just write this on the side. A lot of people always forget this. X to the power of -1. For example, this is just an example now. That is the same as 1 over x, right? To the power of 1. That also means that x to the power of -1/2, well, that would just be 1 over x to the power of 1/2, or 1 over the square root of x. So same thing over here, guys. -1/2, that is the same as 1 divided by the square root of 9 minus x squared. And then, well, the 2 disappeared, but the -x stays, so times -x. I can put that all up into the same, onto just one fraction to make it look a little bit nicer. So -x divided by 9 minus x squared. Whew, okay, that was tricky. And that was just part of the exercise, guys. Oh my god. Okay, we still need to know, well, what is v dash? v dash, right, we'll also need that. Well, 3 plus x, that's a little bit easier to differentiate. That just becomes 1 because the 3 disappears and x differentiated is just 1. Okay, now we're finally ready to use the product rule. Let's just remind ourselves, product rule, that was down here. So we need to say u not differentiated. Okay, what was that? We had that right here. So that would be, so I'll write dA dx is u not differentiated. So 9 minus x squared times what? dv dx, that was v dash, same thing. v dash dv dx, same thing. So times 1. I could also just not write it. Times 1, well, doesn't mean anything. Then plus v. Okay, what was v? That was 3 plus x times du dx, or u dash, same thing. That was negative x. That was the one we put a lot of energy and effort into solving. And there we have it. Okay. Still not quite there, guys, but we're getting closer. We're getting somewhere. At least we have one thing divided by what it should be divided by, the square root 9 minus x squared. But we've got two things, and one of them is a fraction. How do we add them again? How do we turn that into just one thing? Well, there's a very neat trick here. I love this. I can just take my 9 minus x squared, and now I can multiply it by the denominator divided by itself. So look at this. And then multiply it by, multiply it by 9 minus x squared divided by square root of 9 minus x squared. Because look at this. What is this? Something divided by itself, that's just 1, right? So I didn't do anything. That's just a math trick now. So because now we've got a fraction on the same denominator. Okay, then plus, then we can simplify this right-hand side by bringing it all up on the same, just onto the fraction. So just multiplying this on top. Negative x times 3 plus x divided by square root of 9 minus x squared. So, okay, now we just need to get some simplification done, and hopefully we'll end up with that term. If you're lazy and scared you did something wrong at this point, you can do a little bit of a cheat and just say equal to, you know, what it should be. I don't recommend that if you actually know what to do, but if you don't, you might as well. So let's see, let's just simplify this a little bit. I'm just gonna move all of this, you guys, just to have some more space. Just moving all of this over here. Okay, so that is equal to, well, something square rooted times itself square rooted. That's just that thing not square rooted, right? So then we get 9 minus x squared divided by square root of 9 minus x squared. Okay, plus something negative, so I can just say minus maybe. And then I've got x times 3 plus x divided by the square root of 9 minus x squared. Well, what is that equal to? I can expand this. I can multiply the x in, so multiply the x by the 3 and then multiply it by the x. So then I get 9 minus x squared, and now I'm just going to put them all onto the same fraction, right? Because if they got the same denominator, I can just do that. Minus this top thing expanded, that would be 3x plus x squared divided by the square root of 9 minus x squared. Lo and behold, if I now expand this, look at this, guys. 9 minus x squared minus 3x. That minus, of course, you need to be careful here, that multiplies with the plus. That's how we finally get 9 minus 3x minus 2x squared divided by the square root of 9 minus x squared. Wow. Okay, what an adventure, but we made it. We made it. That's a lot of marks, guys. If you got all of that, you can be very, very happy with yourselves. And if you didn't, no worries, this was a tough question. Okay, let's finish this question off with D. Hence or otherwise, find the y-coordinate of R. Okay, what was R again? That was this point right here. So find the y-coordinate of R such that A, the area, is a minimum. Okay, does anyone remember here? What do? We've got a derivative, we need to find a minimum. Ah, right, we need to figure out when the derivative is 0. Okay, So we need dA dx, we need this whole expression, we need that to be equal to 0. Okay, let me just write that up here. So we have got that 9 minus 3x minus x squared. By the way, guys, super important tip right here. Say you didn't manage to do C. A lot of people then don't even bother to read sub-question D anymore. But look, they gave you the answer for C, so even if you didn't manage to do it, you can still solve question D here, right? So please don't make that a mistake. Even if you couldn't do C, still try D. You can get so many points by trying the later questions, even if you couldn't do the earlier ones. Very, very often that's possible. Okay, anyways, back to the question. So we had the derivative 9 minus x squared divided by the square root of 9 minus x squared. That is equal to 0. Okay, I can do my favorite thing on planet Earth right here. If I've got a fraction is equal to something to 0, then I know I can just remove the bottom bit. Because if I multiply both sides, so again, I'll do my long line here. I multiply both sides to get rid of the fraction, 9 minus x squared, right? Then I've got 0 times 9 minus x squared. That just disappears. So what do I have? I do my 3 dots. By the way, whenever I do these, that means therefore. I use them when I've like multiplied something across or added or subtracted something on both sides. Then you have to use the 3 dots. So think of it as like a therefore or because of that. Right? I get 9 minus 3x minus x squared equals to 0. Well, that's just a quadratic. This is a no calculator question, so we have to solve this the hard way. There's 2 ways. You can factorize it if you're good at factorizing. Oh, I've got the 2. Whoopsie daisy. There we go. The 2. Either you factorize it if you're good at factorizing. That's what I'm going to do really quick now. If you are not that good at factorizing, that's okay. You've got the quadratic formula in your data booklet as well. You can just apply that. You'll get the same answer. But anyways, if we factorize this, then we get that. So now I'll do equal to because I'm not manipulating, I'm not multiplying and subtracting on both sides, so I don't need to do the 3 dots. Well, we need the 2x somewhere, and x like so. Then I will probably write this as, let's have a look, maybe negative, and plus 3, and so factorizing this, you would get something like this, and then you know that by the null factor law, either one has to be equal to 0, so we can say either negative 2x plus 3 equals 0. From that, we would then deduce that x is 3 over 2, or we get that, we can write or x plus 3 equals 0, and then from that you would get that x is negative 3. Okay, we got 2 options. Which is the only correct answer, guys? Of course, it cannot be x equal negative 3. That is already the coordinate of p. The x coordinate of p, then all the points would just be in the same. That doesn't make any sense, right? So the answer is x has to be 3 over 2. Okay, but hold up. What do they wanted? They wanted the y coordinate, not the x coordinate. Okay, so then that means we need to take our x coordinate of 3 over 2 and put that into our original equation, you guys. Okay, so then we get 3 over 2 squared plus y squared equals 9. So I just substituted it into this top equation right here. Right, then I need to solve for y, so I subtract on both sides with 3 over 2 squared. Then I get that y squared equals 9 minus 3, well, 3 over 2 squared. Okay, that means that y is plus or minus the square root of, okay, well, 9 minus 9 over 4. So when you square a fraction like this with a bracket around, then just the top and the bottom are squared. So 3 squared is 9, 2 squared is 4. This is not a pretty answer. We can probably simplify this a little bit. Again, we've got fractions we're adding, so we need them to be on the same denominator. So we can do the same trick again. We can say it must be equal to plus or minus 9 times 4 divided by 4 minus 9 over 4. And then finally, we will get that y, okay, so does y have to be a positive or negative number, you guys? Remember r, where was that? That was down here at the bottom. Okay, so then that must be negative, right? So the positive we can ignore now. 9 times 4, ah, goodness me. 9 times 4, that is 36, minus 9, so 27. So we'll get the square root of 27 divided by 4, which we can further simplify to negative square root 27 over 2. Not a pretty number by any means, but it is a result, and we got there in the end. Wow, okay, what a question. Let's take a look at the last question of today. Again, take a quick look at the question yourself, see if you can solve it, and then try with me. So we've got a function h has been defined with something with e. I feel like anything with e always scares people. Just remember, e is just a number. It can't hurt you, I promise. It's just 2.71 something. And yeah, we need to start by finding the value of the y-intercept. Well, I'm sure most of you guys will know how to do this just fine. Again, let's pick a lovely new color. How about this blue? Okay, we need to start by finding h of 0, because that's what the y-intercept is, right? Is when x coordinate is 0. 2 times 0, so I'm just substituting 0 in for x. E to the power of 0 plus 3. Well, anything multiplied by 0 is 0, so that's just 3. Okay, nice and easy start. Find h dash x. Okay, differentiation. Got two things multiplied right here, so again, I've also got it down here. We need the product rule once more. So h dash x, I will not write it out fully with u and v like I did before to save some time, but if you feel like you need it, go right ahead. So first I'll say 2x not differentiated times e to the power of x differentiated. E to the power of x differentiated, that's in your data booklet, but you should also know that's just e to the power of x, right? It doesn't change when it gets differentiated or integrated. Okay, plus 2x differentiated is just 2 times e to the power of x. The 3 falls away. Okay, that was h dash x. Hence, find the coordinates of a. What is a? That's a local minimum. Again, like before, what does a minimum mean? Well, that just means that h dash x at that point is 0. Quick reminder, h dash x, what does h dash even mean? That's the gradient of the tangent, right? So if I draw a tangent right here, well, it'll be a semi-straight line because I'm not so good at drawing. But you can see the gradient of the tangent at a is 0, meaning it doesn't tilt in any way, hence it's a minimum. Okay, so h dash x is 0. Let's just remind ourselves what was h dash. Well, that was 2x e to the power of x plus 2e to the power of x. Well, how do we solve that? I would start by moving the 2ex over to the left side by subtracting it on both sides. Then I get negative 2e to the power of x is 2x e to the power of x. 2 on both sides cancels out. E to the power of x on both sides cancels out. That's nice. Then I'm just left with negative 1 equals x. Most people would stop here, but we will not, because what do they want? They want the coordinates of a, so we also need the y value, not just the x value. How do we find the y value? Well, we just substitute it back into our equation. So we also now need to find h of negative 1 to find the y value. Well, that would be then 2, negative 1 in for x times e to the power of negative 1 plus 3. Okay. Well, again, remember, negative 1, that just means divided by, so this is the same as 3 minus 2 divided by e. Okay, so finally, that must mean that a, it will be the x-coordinate. X-coordinate was minus 1, comma, 3 minus 2 over e. Ta-da! There we go. 2 lines underneath to indicate that's our answer. Make the examiner's life nice and easy. Final question of this video. Show that h double dash is equal to that. Okay, so we just need to differentiate our h dash. Let's just remind ourselves, what was h dash again? H dash x, well, that was 2x to the power times e to the power of x plus 2 to the power of x. Okay, differentiating that once more is thankfully not all that tricky. H double dash of x, well, we've got the product rule once more. We've differentiated this exactly before, so I'll just write it out very quickly. Like so. And then 2e to the power of x differentiated, that doesn't change, that's just 2e to the power of x. Aha, we can add those two guys together, right? So then I get 2x e to the power of x plus 4e to the power of x. Okay, I can factorize the e to the power of x out because it is in both terms. And finally I get 2x plus 4, brackets around it, multiplied by e to the power of x. And the last thing we have to do now is to show for which values of x the graph is concave up. Now, I love this little mnemonic technique, I don't even know if it's a mnemonic, but I know that when, let's just say some arbitrary function f double dash of x is bigger than 0, it is happy because it's positive. That means concave up, so imagine a little smiley looking up like that. That's a very creepy smile, but that's okay. And if f double dash of x is negative, so less than 0, then it is sad. Okay, so we need to find the values where it is happy, where h double dash of x is positive. So let's just write that, h double dash of x, which is equal to, we just showed that of course, but it also says, so again, brilliant exercise here guys, in case you couldn't do di, still try dii, because they tell you the answer, right? So we can still solve this even if we didn't do the previous one, but we know that this has to be positive. Okay, this is always a little bit confusing to some people. How do we solve this now? Well, one thing, e to the power of x is an exponential function, and as soon as you raise a positive number to anything, it doesn't matter what you raise that number to, it can never be negative. Even if I raise it to a negative power, that just means 1 divided by a very big number. It comes very close to 0, but it's never negative. So e to the power of x can never be 0. So anything that you have to change the sign of h double dash of x would have to be with this term right here. So essentially, we can say that if anything had to be negative, it would have to be the 2x plus 4. So that has to be positive. Okay, and then we just solve like we solve anything else. We say minus 4 on both sides. So then we get 2x equals, is bigger than negative 4. We divide by 2 on both sides. I'll do my little line here. This, multiply both sides by 1/2. Same thing as dividing by 2. And I get that x has to be bigger than negative 2. Okay, so I know that when x is bigger than negative 2, I am concave up. Amazing. That's the last question, guys. Thank you so much for making it this far and for sticking with me throughout the entire video. I hope you learned something. I hope you enjoyed it. If you did, please leave a like and comment, subscribe, all that good YouTube jazz. Like I said, there's hopefully going to be a bunch more videos coming up before your exams as well. Or if you're watching this in the future, we will be posting things regularly, I hope. And of course, if you need any help in any subject, be it math, chemistry, English, politics, anything you can think of, we probably have a tutor for you. So feel free to reach out. We would love to help you. And who knows, maybe I'll see you in the next video, or maybe I'll see you in class. Take care. Thank you for watching, guys.